Okay, if you are not in the honors class, then you can cover your hand over your ears and go la 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 because you don't have to listen to this, but you probably want to because you know it's going to be exciting. I want to talk about uniform motion where velocity is constant. So let's look at this problem. It says your friend leaves your house jogging 6 miles per hour. 2 hours later, you leave on a bike traveling at 15 miles per hour, same route. When will you catch your friend, and how far away from home will you be? And I know a lot of you are probably saying, well, just take the car. You'll catch him in about 2 minutes. But you can't do that. That's cheating, so don't. So let me make a table. Okay, so I've magically created a table, and I'm going to use this fact that distance equals rate times time. Okay, now what is my distance? Well, when I catch my friend, I don't know. That's kind of one of the things I want to know, so I'll call it D. What will my friend's distance from my home be? Well, if we are meeting each other, our distances will be the same. That's a nice thing. So that's also D. Now, my rate is going to be 15 miles per hour. My friend's rate is 6 miles per hour. And let's talk about time. It takes me a certain amount of time to catch my friend. I'll call that T. And my friend started 2 hours before me. So whatever time it took me, he has 2 extra hours. Here's another example of writing a variable in terms of another variable. Okay? So now I know that distance equals rate times time. So my distance is 15 times t, and my friend's distance is 6 times t plus 2, and I just set these two things equal because the distances when we meet should be the same. So 15t equals 6 times t plus 2. Distribute. You get 15t equals 6t plus 12. Subtract 6t from both sides. I get 9t equals 12. And then if I divide both sides by 9, 12 divided by 9 is going to give me 1.33333. So 1 1/3 hours, and 1 1/3 hour is 1 hour and 20 minutes. Okay? So I hope you enjoyed that. And better get on your bike and go catch that guy because he's got a head start on you. Actually, one other thing that I want to point out, as you look at this, it says 1 hour, 20 minutes. Now, you might be saying, well, wait a second. I thought the friend was out 2 hours. How could I catch him 40 minutes before he even leaves? But you got to remember, this 1 hour and 20 minutes is 1 hour and 20 minutes plus the 2 hours that he left at. So if you want to talk about it from the friend's perspective, then it actually takes you 3 hours and 20 minutes if you're talking about it from the friend's perspective. So you might have looked at that and said, well, wait a second. How can I catch him before he leaves? Well, that's actually the best way to do it, but that's why that happened. So have a great day and go do some bike riding or some jogging. It's lots of fun.